Large language model agents are doing some just incredible things, right? They can navigate these complex digital worlds, solve these really intricate, multi-step
Yeah,
problems.
his multi-turn tasks.
But here's the thing that's so frustrating. If you put them in a situation where they have to, actively explore or learn through trial and error, they can be surprisingly brittle.
Mm-hmm.
And standard reinforcement learning, it just doesn't seem to teach them how to be good explorers.
And that inability to adapt on the fly, that's really the ceiling for current LLM agents. So today, we're going to get into the solution proposed in the paper. Meta-RL induces exploration in language agents.
Ah, the LaMer framework.
That's the one. Our mission here is to understand how this Meta-RL approach teaches these agents not just what to do, but, and this is key, how to learn a generalized strategy for active exploration.
Okay, let's break this down. We know RL helps LLMs with these long horizon tasks, but why do they fail so badly at exploration? I mean, if they're getting feedback from the environment, shouldn't they already be learning?
Well, you'd think so, but a standard RL agent is really just optimizing its actions within a single go, a single episode.
So if it fails, it just starts over.
Pretty much. It goes back to square one without really changing its fundamental approach. LaMer is different. Because it uses Meta-RL, it's actually teaching the agent a generalized strategy for exploration.
And it does this at test time?
Yes, it learns from the feedback and adapts its policy at test time.
Okay, hold on. If RL agents already get environment feedback, what does at test time feedback even mean here? How is that different?
Think of it this way. In regular RL, you train the agent for months, right? Then you deploy it. If it hits a new scenario, it's back to the lab for a complete retrain,
A huge gradient update.
a huge, costly one. With LaMer, the agent is built to use the immediate feedback from a failed task, right then and there, to adapt its strategy for the very next attempt. It's learning the skill of adapting itself.
That makes so much more sense. It's a principled approach, not just a patch.
Exactly.
So let's get into the mechanics. The first big component is this cross-episode training framework. This seems pretty fundamental. Why train across multiple runs?
Because exploration isn't always immediately rewarding. I mean, if you're solving a complex puzzle like Sokoban, you might have to make a few moves that seem wrong in the short term.
Just to see what happens.
Right, just to unlock the path to victory later on. Cross-episode training forces the agent to look at that long game. It learns the value of information, even if that information comes from, a temporary failure.
So it encourages that proactive, exploratory mindset.
That's the goal.
That long-term view is smart, but for real adaptation, you need speed. Which brings us to the second part, which sounds really innovative. In-context policy adaptation via reflection.
Mhm.
The paper says this happens without a traditional gradient update. I mean, that sounds a bit like magic. If it's not heavy model retraining, what's actually driving that learning?
It's just a much more efficient way to learn. Imagine you're trying a new video game. You fail the first round, and you immediately think, okay, next time I need to check my inventory first.
That quick mental note.
That's reflection. The LLM agent does the same thing. It reflects on the error it just got, internalizes that lesson, and modifies its own internal strategy for the next episode.
So it's an immediate, lightweight adaptation. It just bypasses that whole massive, time-consuming update process.
And that's the novelty right there.
And the evidence shows this works. The quantitative results are pretty clear. LaMer significantly improves performance over the standard RL baselines.
Yeah, the numbers are impressive.
It's an 11% boost on a spatial reasoning task like Sokoban, 14% better on MineSweeper, and a really substantial 19% gain on Webshop.
And so, what does this all mean for you listening? It's not just about better scores. What LaMer really demonstrates is robust generalization.
Ah, so it's not just memorizing solutions.
Not at all. Because the agent has learned how to explore and adapt its strategy, it performs well even on harder or totally unseen tasks. It's applying a learned meta skill to figure out new paths forward.
So the central finding that Meta-RL is a robust and highly efficient way to create truly adaptive language agents, that's a huge step forward.
It really is. And it leaves you with a pretty provocative thought. If LLMs can learn these generalized exploration strategies through reflection, what complex unseen tasks in the real world think scientific discovery or maybe global supply chain optimization will they be able to solve next? The era of self-improving agents is, well, it feels like it's finally here.